This video focuses on subnetting and how to find your subnetworks easily and quickly using the magic number trick. Let's say we're subnetting a 192.168.1.0 network /24. I have the IP address and subnet mask in decimal here, and I have them listed in binary here. The network portion of the subnet mask and the host portion of the subnet mask. To subnet this network, what I can do is I can borrow 1 bit from the host portion of the subnet mask, and now I have 1 subnet bit. This changes the subnet mask from /24 to /25. If I borrow 1 bit from the host portion, I have 1 bit, or 2 to the first power, makes 2 possible subnetworks. The subnetworks I've created are the 192.168.1.0 subnet and the 192.168.1.128 subnet, both /25. The hosts on each network are 126 usable hosts. We have 7 zeros here, and 2 to the 7th power is 128, minus 2 makes 126 usable hosts per subnet. If I decide to borrow 2 subnetwork bits from the host portion of the original 192.168.1.0/24 network, I now have /26. I've borrowed 2 bits, so now I have 2 to the 2nd power of subnet bits, so I have effectively 4 subnetworks. The 4 subnetworks are listed here. For host bits, I have 6 zeros in the host portion of the address, and 2 to the 6th power is 64. Minus 2 for each subnet makes 62 usable hosts per subnet. The subnetworks that are created are the 192.168.1.0 subnet, the 64 subnet, the 128 subnet, and the 192 subnet. Notice how the number of borrowed bits and the number of host bits determines a lot about the subnet. If I borrow 3 subnetwork bits, I now have a /27, so it goes from /24 to /27. I have 3 subnet bits. 2 to the 3rd power is 8. 2 times 2 times 2 is 8. And you can see that I now have 8 subnets, or 8 subnetworks, created from the original 192.168.1.0 network. Each subnet is now /27. Notice that there are now 32 hosts, or 30 usable hosts, per subnetwork. We could go up to /28, and now I have 4 subnetwork bits. Notice that the subnet mask has changed from 255.255.255.0 when it was /24 to now 240. I now have 16 subnetworks, or 2 to the 4th power, and there's 2 to the 4th power of hosts per network, so there's 16 or 14 usable host addresses per subnet. Borrowing 5 bits looks like this, and borrowing 6 bits looks like this. I've now borrowed 6 bits from the original 8-bit host portion of the original /24 network, and I now have 2 to the 6th power of possible subnetworks, meaning I have 64 subnets. The host portion of the address is now only 2 bits, or 2 to the 2nd power, meaning there's only 4 host addresses per subnet. Now, if you have 4 host addresses, you have to leave room for the network address and the broadcast address, so 4 minus 2 leaves only 2 usable hosts per subnet. Typically, on a LAN, we do not go higher than a /30 subnet mask. Otherwise, you'll not have enough room for usable host addresses. In other words, we can't borrow any more bits from the host portion, or we won't have enough addresses for hosts. You might be asking yourself how I was able to discern the different subnetworks from the subnet mask or subnet bits that were borrowed. There are many different ways to derive the subnetworks from the subnet mask, but my favorite is the magic number technique. The magic number is simply the place value of the last one in the subnet mask. So in this situation, we have a /25 subnet mask. We have 25 ones, and the last one is the one here all the way on the right, highlighted in red. This one, if we look at it according to this octet, is in the 128th place. If we think about the place values of 8 bits, this is the 128th place. So the magic number in this situation is 128. The magic number tells us where to find the networks. It tells us that the networks will go up by 128. So in this case, the first network, which is always 0, so 192.168.1.0/25, and from there the networks go up by 128, so the next network is 192.168.1.128. Let's see how this works borrowing 2 bits from the host portion. Now I have borrowed 2 bits from the host portion of the subnet mask. The magic number is now the last binary one, which in this case is in the 64's place. So the magic number is 64. The magic number tells us how to find our networks and lets us know that the networks will be going up in increments of 64. So for instance, the first subnet is always 0, so 192.168.1.0/26. The next subnet is 64. 64 plus 64 is 128, and 128 plus 64 is 192. You can see how the subnets are going up by 64. There's only 4 subnets because we've borrowed 2 subnet bits. Also, we can go no higher than 192 because 64 plus 192 is 256, and that's too large a number. Let's see how it works with 3 bits. With 3 bits, we now have a /25, 26, 27 subnet mask, /27 subnet mask, in decimal 255.255.255.224. The last one in the subnet mask is our magic number. In this case, it's in the 32's place in the binary conversion table. So the magic number is 32. If we look at the networks, we'll see that they go up by 32. The first network being 0, 192.168.1.0/27, then the 32 subnet /27, 64, 96, 128, 160, 192, and 224. The subnets go up in increments of 32, following the magic number. Now that we see the pattern and how the last borrowed bit affects the location of the subnetworks, let's try it with a /28 subnet mask. Now I have the 192.168.1.0/24 network. I want to subnet it, changing it to /28. /28 means I borrow 4 bits in the subnet mask, so I now have 28 ones counted from left to right. 255, 255, 255, 240 subnet mask. 128 plus 64 plus 32 plus 16 is 240. The last one is in the 16's place. This is the 128's place, the 64's place, the 32's place, the 16's place. So the magic number is 16. We'll see that the networks go up by 16. The first network is always 0, so 192.168.1.0/28. I'll copy this and paste it, and the next network will be the 16 network. Why? Because the magic number is 16, because the last one is in the place value of 16. The next network will be 32. And the following network will be 48. And after 48, 64. And so on and so forth. The networks will go up by 16. In each network, we have the host bits, 4 bits for hosts, which is also 2 to the 4th power 16. So the network will go from 0 up to 15, with 0 being the subnetwork address or network address, and 15 being the broadcast address, and the next subnet is the 16 subnetwork. Now let's try creating /29 subnets. We can see that that involves borrowing 5 bits from the host portion of the subnet mask, and that the last one is in the 8th place. So the magic number is 8. The networks will go up in increments of 8. So starting from 0, we'll have the 8 network, and the 16 network, and the 24 network, and so on and so forth, all subnets being /29. For the /30, we see that the last one is in the 4's place, and that the networks will go up by 4. So similarly, the networks will go up in increments of 4. So the first network is the 0 network, then the 4 subnetwork, then the 8 subnetwork. Each subnetwork will have 4 host addresses, in this case 0 to 3. 0 will be the network address, 3 the broadcast address, and the addresses between 1 and 2 will be the usable host addresses. Only 2 usable host addresses in a /30 subnetted network. You might ask yourself, will this technique, the magic number technique of looking at the place value of the last one in the subnet mask, work in other subnetted octets? In other words, if we're starting from a class B /16 network address or a /8 class A network address, would this technique work? And it does. For instance, if we take a 172.16.0.0 network /16, you can see in this scenario I've subnetted it to a /23 subnet mask. In other words, I've taken the original 16 network bits and borrowed 1, 2, 3, 4, 5, 6, 7 ones from the host portion of the subnet mask. In this situation, the last borrowed one is in the 2's place. So the magic number in this situation is 2. This means that the subnets will go up by 2 in this octet here. So in other words, our first subnet will be 172.16.0.0 /23, and the next network will be 172.16.2.0 /23. The only difference is now, instead of 16 host bits like we would have had in a /16 network, we now have 9 host bits, so 2 to the 9th power, meaning we have 512 minus 2 would be 510 host addresses that we can assign. In other words, the network goes from 0.0 all the way up to 172.16.1.255. So the first usable host address would be 0.1, and the last usable host address would be 1.254. The next subnet starts at 2.0. After that, the networks continue to go up by 2. In other words, the next subnet will be the 4 subnet, and then the 6 subnet, and the 8 subnet. Notice that the networks are going up by 2, but in the 3rd octet, not in the 4th octet. The only difference not to be confused on is the larger number of host addresses that you'll experience when you subnet in this octet or in the 2nd octet. You can see how the magic number technique can help you quickly locate the networks or subnets